This is part 2 in our exploration of the slope of the sine function. In part 1, we approximated the slope of the sine function at a point A by constructing a secant line through points A and B on the graph. We then dragged point B so that it was close to point A. We realized that the slope of the secant line seemed to give a good approximation of the slope of the sine function at point A. This approach, however, had one problem. Dragging points A and B close to each other was possible. Dragging them very, very, very close to each other is not possible. There's a limit to how close these points can be. And if we'd like this approximation to be as good as it can be, we really need to think about another way to do this so that we have precise control over that distance, horizontal distance between the 2 points. So in this new investigation that continues where we left off, we're going to determine the horizontal distance between those 2 points by using a parameter. And a parameter is simply a number whose value we can change. So let's see what all that means. I'm going to start by putting a point directly onto my graph and using the measure abscissa tool to measure its x value. As I move through these steps, I'm going to move a little bit faster than I did in my first video because I assume by now you're comfortable with the nuts and bolts of how these tools work. I also now want to find the y value of point A. And to do that, I'm going to use the calculate tool and tap directly on my f of x and then directly on x sub a to compute f of x sub a. So here we have the x and the y value of point A. Now the other point that will determine the secant line, I am going to use a parameter to help create that. So I'll tap on the parameter tool, tap to add a parameter, and let's change that parameter to a friendlier name. Let's call it h. So the second point is going to be a horizontal distance of h away from point A. So I'm going to compute x sub a plus h. The y value of this point I'm going to determine by plugging it right into my function. So here's the y value. And let's plot that point, x value and the y value, and we see it's right here. As I drag point A, that point moves along with it, and the horizontal distance between those 2 points is always given by h. So now, as we did in our last investigation, I'm going to connect these 2 points to make a secant line. And I am going to now compute the slope of that secant line because that's going to give us the approximation of the slope of the sine function at point A. So I'm going to use the calculator and compute the difference in the y values. And the difference in my x values, well, that I know. That I made specifically to be equal to h. So I'll just tap on h to add that to my computation. So here we have the expression for the slope of the secant line. Now, as I did in part 1 of this investigation, I'm going to plot a point, and the x-coordinate of that point will be x sub a, and the y value will be the slope at that point, the approximation of the slope of the sine function at point A. So here is that point. Now I can drag point A along here to see how this point that represents the slope changes. But as we saw before, it's kind of choppy. So let's use an animate point button to make that much smoother. Okay. And let's also trace this point. Now right now, this is not a very good approximation of the slope of the sine function at point A, because h is equal to 1. Well, we have an easy way of making this distance between the points a lot smaller. We can simply type in a new value. So how about we use 0.01? And notice what happens when we enter that. Our secant line, where we saw both points clearly, now we really just see one point. And it looks a lot like the tangent line. Now we really do have 2 points, so it's not the tangent line, but to my naked eye it certainly looks like it, and a lot better approximation of the slope. So we can animate that, and we see the trace of the slope. And that looks, as we saw in our prior investigation, an awful lot like the cosine function. So let me stop this again. So, okay, we have this approximation of the slope, and it's certainly way better than we could do before when we dragged the points to be close to each other. But we're not being greedy enough. We only have set h to be 0.01, and we could do better. So how about 0.00001? We can't really see that difference, but we know that this is an even better approximation of the slope, and that this is even closer to approximating the tangent to the graph. And if we wanted to be even better, we could set smaller and smaller values for h. And all of this leads the way to the more conceptual and algebraic development of derivatives. But starting with this, certainly, I think at least, gives students a way more intuitive introduction to what it means to compute the slope and the derivative. So we hope you've enjoyed this 2-part series looking at the slope of the sine function.